Hi everybody, in this video we will discuss section 3 of chapter 6, factoring trinomials of degree 2, and now the leading coefficient will be something other than 1. Hey, we'll just call it a. So what are we going to do here? We are going to learn how to use the AC method to factor trinomials. Now when I say AC, I don't mean alternating current. I also don't mean AC-DC. No, I mean the AC method. So what is this method all about? Well, let's use this polynomial, or this trinomial, 2x squared plus 9x plus 10 as an example. First thing we're going to do is we're going to take A, and we're going to take C, and we are going to multiply them together. And here in this example, we'll take 2 multiplied by 10 and get 20. Then we are going to find two integers that are 1, factors of the product, i.e. factors of 20, that sum to B, which in this case is 9. Now clearly the factors of 1 and 20 don't work, neither do negative 1 nor negative 20. 2 and 20 don't work, they both sum to positive 12 and negative 12 respectively. However, 4 plus 5 are factors of 20 and they equal 9. That is what we want. Now, if it turns out that you cannot find factors of 20 that sum to the middle term or the linear term, then in that case, the trinomial is not factorable. Okay, once you've done that, well then we want to replace the middle term, 9x, by those two integers that you just found. In this case, 4x plus 5x. Now take a look at what we have. We've changed our trinomial and turned it into a quadnomial, for lack of a better term, a quadnomial or a fournomial. As a consequence, this is now a candidate for factoring by grouping, which we actually learned 2 lessons ago. So what do we want to do? We want to factor this using the factor by grouping technique that we learned in section 6.1c. And so we will, and in this particular case, there's really only one way to group these so that they work, and that is to group the 2x squared and the 4x. Here we go. And now we're going to group the 5x and the 10. Here we have a common factor of 2 and x. We have a factor of 2 here, a factor of 2 there, and this one has 2 x's. As once we can factor out a 2x. Here we have a common factor of 5, so we can factor that out. And then we can factor out our binomial term, and we are left with the quantity 2x plus 5 times x plus 2. And then what you might want to do is check this through the use of FOIL, and if we do, we will have 2x times x, 2x squared. 2x times 2 is 4. 2x plus 5x is 5. They combine to 9, and then finally 5 times 2 is 10. And there you go. You've done it. And that is the AC approach. Now, there are a couple of things you want to think about when you do this. The first thing is you always want to check to see if that trinomial has a greatest common factor. If it is, you want to factor it out. However, you want to make sure you include that in your final answer, or it's going to be wrong. And Hawks and perhaps myself will yell at you. Remember, to factor a polynomial completely, you actually have to find factors that can no longer be factorable. So if you actually factor something and there is still something that you can factor, you're not done yet. And then next, not all polynomials are factorable. Once again, we want to find if there are no factors of the product AC that sum to B, then that sucker is not factorable. And finally, it is easy to check to see if your factoring is correct. So I would encourage you to check. It doesn't take much time. Just knock it out. That way you know you're right, or you know that there's a problem. Okay, so it is time to do some examples. And here they are. And I'm going to do them differently this time. I actually have these samples on OneNote right here. And so we will work them in OneNote. So the first thing we want to do is see if there is a greatest common factor. In this case, we have 4, which factors to 2 times 2. We have 33, which factors to 2 times 11. And we have 3 times 11, I'm sorry. We have 35 that factors to a 3 times 7. So all these are prime numbers. So this is our prime factorization for all these. They are all different. So there is no greatest common factor. Okay, So now we can multiply, we can find the product of 4 and 35. 4 times 35. Well, 35 times 2 is 70. 70 times 2 is 140. So that is our factor. Or that is, I'm sorry, so that is our product of A and C. Now we want to find factors of 140. So what are the factors of 140? Well, there's 1 in 140, but that sums to 141, so that's not going to work. There is 2 and 70. Well, that sums to 72. Okay, well, 3 is not a factor of 140. What about 4? Well, that's 4 times 35, and that sums to 39, so that's not going to work. What about 5? Well, 5 times 28 is 140. 5 plus 28 is 33. So this is it. That's what we're looking for. So we can rewrite this. So now we can rewrite 33. We can rewrite the trinomial by replacing 33x with 5x plus 28x. So let's go ahead and do that. And actually, when I write this, what I'm going to do, I'm going to write this as 4x squared plus, okay, let's just do it this way, 5x plus 28x plus 35. Okay, now we can do factoring by grouping. Now, we could group the 4x squared and the 5x, but if we did, then we were going to have well, actually, we actually can go ahead and do that. Let's do that. So we can group 4x squared and 5x. There we go. And then we can group 28x and 35. There we are. Now here we have a x that is in common. That we have our common factor here is x, so we can factor that out, and we will have x times 4x plus 5. Over here we have 7 times 4, 7 times 5, so we can factor out a 7. And then we will have 4x plus 5. I forgot the plus over here, sorry about that. Now I have a common binomial term that I can factor out, and when I do, I will have 4x plus 5 times the quantity x plus 7, and that will be our answer right here. Does it work? Well, let me see. We have 4x times x, that's 4x squared. 4x times 7 is 28x. X times 5 is 5x. 5 times 7 is 30x. 5 times 7 is 35. And yes, it works out. Okay, for our next one, we have 4x squared plus 5x minus 6. Correction, 4x squared minus 5x minus 6. Now, is there a greatest common factor? Well, here we have 2 times 2. This is just 2 times 2. This is just 5 times 1, or 5, and this is 2 times 3. So the answer is no. So what we can do is, once again, multiply A times C. Okay, and that will give us 4 times 5. Correction, let me do that again. 4 times negative 6, because here C is negative 6, and that will give you negative 24. Now we want to find factors of negative 24 that will sum to 5. So let's see if we can figure those out. All right, so we have negative 1 and 24. That will sum to 23. We have negative 2 and 12. That will sum to 10. We have negative 3 and 8. That will sum to 5. And then we have negative 4 and 6. Which will sum to 4. Okay, and you can almost see that we'll reverse the sign of these factors, and we'll actually get what we want. But let's just walk through the thing. Let's just walk through it one more time, and then we will have 1 and negative 24, which is negative 23. We will have 2 and negative 12, which is negative 10. We will have 3 and negative 8, which is negative 5 And that is what we are looking for right here. Okay, so now so that is pretty much step 2. For step 3, we can replace the 5x with 3x minus 8x, and that will give me 4x squared minus plus 3x minus 8x minus 6. Okay, and now we can go ahead and do our factoring by grouping. Okay, in this one, we can group the 4x squared and the 3x. Okay, and then, well, actually, I'm going to need to write this again. We can group the 4x squared and the 3x. And then I can group the negative 8x and the minus 6. Okay, awesome. Now over here, I can factor out an x. That's the only common factor that I have. So here I have x times 4x plus 3. Over here, I can factor out a 2. And that will give me plus 2 times negative 4x minus 3. Well, they're not the same. They're the opposites of each other. So I can actually factor out a negative 1 as well. And then that would give me x times the quantity 4x plus 3 minus 2 times the quantity 4x plus 3. Now I have a common binomial factor. And I can now factor out the common binomial term. And if I do, I will have 4x plus 3 times x minus 2. Let's go ahead and check. We will have 4x times x, that's 4x squared. I will have 4x times negative 2, that's going to be negative 8x. 3 times x is positive 3x. And then we have a negative 6. And combining that, I have 4x, combining the like terms here, negative 5x, 4x squared, negative 5x minus 6. So this and this are the same, and everything checks out. Okay, so let's do another one. Here we have 12y to the cubed minus 26y squared plus 12y. Now this one has a greatest common factor. Notice that the prime factorization for 12 is going to be 4 times 3, or 2 times 2 times 3. The prime factorization for 26 is going to be 2 times 13. 13 is a prime number. And then once again, we have 2 times 2 times 3. Here we have a y, 2 y's, and 3 y's, so each one has at least has a common y. So in that particular case, the greatest common factor is going to be all the prime factors that are in common. That's just 2, and then y. So the greatest common factor in this particular case is 2y. So we can factor this into 2y times whatever we need to multiply 2y by to get 12y cubed, which will be 6y squared, all right, times minus 13y plus, once again, whatever we need to multiply 2y by to get 12y, that's going to be plus 6. All right. Now, once we've done that, we want to factor this. So the first thing we want to do is find the products, is compute a times c, which is going to be 6 times 6, which is 36. Okay, now we want to find factors of 36 that will sum to negative 13. So we know for a fact, since we have a positive 36, those factors, both factors are going to be negative. Okay, so for 2, we have 6. We have negative 6 times. I got ahead of myself. We have negative 1 times negative 36. Well, that's going to sum to negative 37. That's not going to work. We have negative 2 times negative 18. That will sum to negative 20. We have negative 3 times negative 12. That will sum to negative 15. We have negative 4 and negative 9, that will sum to negative 13. So negative 4 and negative 9 is what we are looking for. So for step 3, we can replace the negative 13 with negative 4 plus negative 9. And that will give us 6y squared minus 4y minus 9y plus 6. Okay, great. Now we can actually factor by grouping. So here we can group this as follows. In 4, we can group these two together because they have a common factor, and we can group these two together. So here we have 6y squared minus 4y. And then over here we have plus negative 9y plus 6. Okay? Here we have a common factor of 2 and a y. So here we can factor out a 2y. And then what do we need to multiply 2y by to get 6y squared? Well, that would be 3y. All right, minus, what do we need to multiply 2y by to get negative 4y? That's just 2. Plus, now here we have a common factor of 3. All right, what do we need to multiply 3 by to get negative 9y? Well, we need to multiply that by negative 3y. And what do we need to multiply 3 by to get 6? Well, that's just positive 2. All right. Now notice that these are not the same, but they are opposites of each other. So once again, we can factor out a negative 1. That will give us a minus 3 here, and then a 3y minus 2 here. And of course, I can bring this down. Okay, and then I can factor out the common binomial term. And if I do, I will have 3y minus 2 times 2y minus 3. Okay, now what here is missing? Well, what's missing is this 2y here, the greatest common factor. We need to also include the greatest common factor, or it's not going to work out right. And if we do, so we need to add the 2y here. And this is 12y cubed minus 26y squared plus 12y factored. Does it work out? Well, once again, we can go ahead and do FOIL, and that will give us 3y times 2y, which is 6y squared. 3 times negative 3 is minus 9y. Negative 2 times 2y is minus 4y. Negative 3 minus negative 2 times negative 3 is positive 6. All that gets multiplied by 2y. That will give me 12y cubed minus 18y squared minus 8y squared plus 12y. And then combining like terms, we have 12y cubed minus 26y squared plus, I forgot the 1 there, plus 12y, and it checks out. This and this are the same, so we know we are good to go. Okay, so now I'm going to go ahead and get Hawks going, and I will be back once it is up and running. Okay, so here we are, and let me continue with. Let me go to practice. As you can see, I've been playing with this just a little bit, and so let me get back to where the beginning is. Okay, so let's take a look at this one. Here we have 8y squared plus 6y minus 5. Okay, so let's take a look at 8x squared plus 6x minus 5. Okay, the first thing we want to do is check for greatest common factors, and this factors to 2 times 2 times 2. This factors to 2 times 3, and this is just 5 times 1, so there is no greatest common factor. So now we can go ahead and multiply a times c. Well, a times c is going to be 8 times negative 5, which is going to be negative 40. So we have 8 times negative 5, which will be negative 40. Now we want to find factors of negative 40 that will sum to positive 6. Okay, so the first factor would be probably 40 and minus 1. Notice how I want, since I'm looking for a positive 6, I want the factor with the larger absolute value to be positive. Okay, so that's going to be negative 30. That's going to be 39. That's not going to work. What about 20 and negative 2? Those are factors of 40, and that will be 18. Not quite, but getting closer. 3 does not divide to 40. Well, 4 does. So there we'll have 10 and negative 4, and that will give you a positive 6. So this is what we're looking for. So now I'm going to replace my linear term 6y with 10y minus 4y. Why? Well, because then I could factor it. And here I will have 8y squared, replacing 6y with 10y minus 4y. I'm going to have plus 10y minus 4y minus 5. Now, in this particular case, now I want to, so this is what, well, this was 2, and this is 3. Now I want to factor by grouping. Now, I could combine the 8y squared and the 10y, but if I do, I'm left with a negative 4y and a negative 4y and a negative 5, which may not work. But then again, maybe it will. Let's find out. So let's go ahead and combine it like that. Let's go ahead and we're going to have 8y squared plus 10y. And then over here we're going to have plus minus 4y minus 5. Okay? Well, here I have a common factor of 2 and a common factor of y. This is 2 times 4. This is 2 times 5. Okay, so I can factor out that 2y. And then I am left with 4. 2 times 4 is 8, so 4, and I have 1y here. I need another one. There's my y. And then if I have 2y on the outside, I need to multiply that by 5 to get 10y on the inside. And over here I have minus 4y minus 5. Now, are the binomial terms the same? No, they are not, but notice that they are opposites of each other, and there should be a plus here. I apologize. They are opposites of each other. So I can actually basically factor out a negative 1 by replacing a plus with a minus, and then replacing the negative 4y with a positive 4y, and the negative 5 with a positive 5. Okay, and then I can bring my 2y down here, my 4y plus 5 down here, and I am good to go. So here I have a common binomial term. There is an implied coefficient of 1 here. So I can write this, I can factor out the 4y plus 5. And now we'll have 4y plus 5 times 2y minus 1. Is this going to work? Well, 4y times 2y is 8y squared. 4y times minus 1 is negative 4y. 5y times 2y is positive 10y. And then 5y times minus 1 is minus 5. And the negative 4 plus 10 is 6. So this should indeed work. And there you go. Okay, well, most of these are pretty much the same, and that actually is the harder one of the problems. So let's try something else. Let's try this one right here. P squared plus 15p plus 5. Well, I'm sorry, p squared plus 15p plus 15. Well, there's nothing factorable here. There's the greatest common factor happens to be 1, so we don't need to worry about factoring out a greatest common factor. Okay, so now we want to multiply a, which is 1, by p, which is 15. And that will give me, well, 15. Actually, if you wanted to, you could actually use the approach in section 6.2 to actually solve this. But let's go ahead and solve this by grouping. Here we're going to multiply a times c, that'd be 1 times 15, which will give me 15. And now I want to find all the factors of 15 that will sum to, well, 15. Well, we have 15 and 1. That sums to 16. And then the only other factor is 3 and 5, which sums to 8. Those are the only factors of 15. None of them sum to 15. As a consequence, this is not factorable. Okay, and so we can go ahead, although this is a different problem, This might give you a hint as how this goes. I can click not factorable, submit my answer, and it is correct. And that is pretty much this lesson in a nutshell. If you have any questions, please feel free to contact me. And this is Bob Boyle, signing off.